Today we will do the derivation of kinetic energy. Now, let's start writing this. Suppose an object of mass m moves because of an applied force F. So, we are applying a force F because of which the body is moving, because of the applied force F. Correct? Then, let U be initial velocity. Now, how much is U in this case? Because of an applied force. So, initially it is at rest. So, U is equal to 0 meter per second. Right? Then, initial velocity, the force applied is F. This generates an acceleration. So, acceleration A is the acceleration because of the applied force. It's the acceleration because of the applied force. Then the velocity of the object becomes V in time t. It becomes V in time t. Okay. Then displacement is S. Okay, so this is my dialogue which I have to give before I start the derivation. Displacement is S. Right? Now, very simple. We know that. Work done is equal to F dot S. Okay, F dot S. But what is my force equal to? My force is equal to mass into acceleration. This is Newton's second law of motion. Correct? Now, we also know that S is equal to ut plus half at square. Therefore, S is equal to, what is U equal to? 0. So, this will become 0. So, S is equal to half at square. S is equal to half at square. So, therefore, we can say that, okay, now let's do away with this. Okay, I'm just writing these steps again. Okay, so once again I repeat, work is equal to force into displacement. Force is equal to mass into acceleration. S is equal to half at square. We got these three, right? You don't write this again. You don't have to write this again. Therefore, work is equal to, instead of F, can we put m dot A, okay, and instead of S, can we put half at square instead of S we are putting half AT square. So this becomes half into M into AT, the whole square, because A into A square, T square. So AT the whole square. But what is V equal to? U plus AT. What is U? 0. So V is equal to AT. Therefore, if I want V square, I will say V square is AT the whole square. Therefore, my work is equal to half M. Instead of A square T square, what can I substitute? Now, it's a moving object. Okay, it's a moving object, right? So therefore, work is equal to kinetic energy. Therefore, kinetic energy is equal to half mv square. That's how I got my kinetic energy is equal to half mv square. Okay, now derivation. Now we will do the derivation for potential energy. Derivation for potential energy. Okay, to carry an object to carry an object of mass m of mass m to carry an object of mass m to a height h, to height h above the surface of the earth, above the surface of the earth, above the surface of the earth. Okay, now force applied is equal to m. So it is above the surface of the earth, to mg. Correct? Because it is above the surface of the earth, it is mass. See, force is mass into acceleration, but this force is mass into acceleration due to gravity. Why? Because this is an object, you are lifting it above the ground, right? So it is mass into gravitational acceleration. Now, as usual, work is equal to F dot S. Now we are lifting the body to a height h. Force is m into g, height h above the surface of the earth. So work done is equal to mgh. Now this work done is stored in the body, so it is equal to the potential energy. Therefore, potential energy is given by the formula mgh. mgh. These are the two derivations for